So, welcome everyone. My name is Nick. I'm senior data engineer at Stripe on Growth team, and we're going to spend this team talking about machine learning and my experience of using Jupyter Notebooks in production. For the full disclosure, this talk is not about my work. This talk is about my work at previous company, not at Stripe, for you to understand the whole context. So I started my career as a full-stack backend engineer, messing around with shopping carts, payment systems, and at some point I just got tired of doing another payment integration and decided to pivot my career towards complex data and shiny machine learning. And ever since, I had a lot of fun building data pipelines, working with data scientists, and shipping ML models to production. Last year, I did a big move and relocated from Germany to beautiful British Columbia. As you can see from my hobbies, it looks like it was the right move. And so far, I have no regrets, despite the rain and traffic jams on the Lion Gate Bridge when I'm going back from Easter. Let's begin with the talk. And in order for you to better understand the choices that we made and the route that we chose, it's important to understand a bit of the background of my team and how did we start. Back then, my team was just two people, myself and responsible for development and manager who was responsible for data science part. A few months later, when we started, one more data scientist joined our team. So we started as a pretty small, lean team, but with a lot of ambitions and work to do. Today, I'm going to talk about product and different use cases. I've been working at Delivery Hero back in Germany. A bit about Delivery Hero. It's actually one of the biggest food deliverers in the world with big market presence in Asia, Middle East, and South America. As you can see from the map, it kind of a lot of different brands. And one of the main kind of differences between Delivery Hero and DoorDash or Uber Eats, it has different brands in each country. That's why the brand Delivery Hero itself is not really known. But if you ever visited those countries or you are from one of those countries, you might see the brands such as Food Panda in Asia, Petidosha in South America, or Glovo, which is present in Africa and Europe. The main HQ of the company is located in Berlin, Germany, together with the main development center, and we had around 5,000 people working in development in Berlin. There are many other small offices located in key markets, and they mostly focused on the different local use cases. Our first customer when we just started with my team was Food Panda with operations in Asia, and the main objective for us was to improve food delivery time estimations. When we think about delivery time of an order, we can assume that people complain about only the fact when the food was late. But in fact, when the food arrives too early, customers feel unsatisfied. And the reason for that, because a lot of people, they're ordering food being on the go to work or home. As well, delivery time estimate is one of the main drivers for customer to choose the particular restaurant, because usually they want to get food as soon as possible or in some time frames that are most suitable for them. Therefore, estimating the delivery time of an order is an important part of ensuring a positive user experience for a customer. Delivery Hero in most of the markets has two types of the delivery, either own delivery logistics, which we call in the company own delivery, or it relies on delivery of the order by the restaurant themselves, which we would call vendor delivery. The data-driven method for estimating delivery times requires certain signals, with the help of which we can approximately know the time when the previous order was actually delivered based on different signals. For example, in the case with our own delivery, we precisely know when the order was placed by the user, when it was delivered, when it was picked up by the courier, because we get all those signals. And the difference in all those values give us precise estimate when our customer can expect the food. Unfortunately, in the case with restaurant delivery, we rarely know what happened to the order after it was placed by the user, because we heavily rely on the restaurants itself and on the fact that they're supposed to do some action and send us some signals. In fact, quite often what happens, restaurants, they just forgot to press the button, hey, order was picked up by our courier. And that's why we rarely know when it was delivered to our customer. In this case, we need to rely on different secondary signals to give us a bit of the overview of what is actually going on and ability to correctly make some estimates when order will be delivered to our customer. This exact problem we are trying to solve with my team at the beginning. So let's quickly jump to the technical part. The first candidate that we're going to talk about, and the main one, is of course Jupyter Notebooks. I'm not going to go too much into detail about Jupyter Notebooks, since it's not really the purpose of this talk per se, but I give a slight overview for people who is not familiar with the topic. So the Jupyter Notebooks, one of the most popular and kind of long-lived tools when it comes to data analysis and model development. At its core, it's development environment available in any browser and allows you to use code formulas, various graphics, and images in one place. The good thing about Jupyter Notebooks, it makes it really easy for you to execute your code in the browser, do quick prototyping, and in Jupyter Notebook, you can iterate really quickly with different analysis or model development, and execute and rerun every single line of your code without running the whole notebook itself. Jupyter Notebooks consist of two main components. It's web interface, where you're actually writing your code, and the server part, which executing the code that you've written. Typically, Jupyter Notebooks, they're typing and developing, and really for running production pipelines. Though it might be quite a powerful tool, there are brave people such as Netflix and us who use Jupyter Notebooks in production. As much as we love Jupyter Notebooks, there are still some downsides of using just vanilla notebooks. For instance, it's lack of collaboration, it's difficult to test, and quite difficult to include Jupyter Notebooks in typical development life cycle, such as review, CI/CD, which brings you to the point that if you just take vanilla Jupyter Notebooks, it's not really easy to make it production ready without some extra effort. Given all of this, topic of using Jupyter Notebooks in production always raises heated discussions, and you can simply get lost in dozens of Reddit threads when people trying to convince you how crazy you are, even thinking about using Jupyter Notebooks for your production pipelines. From our side, we're not afraid to take this challenge, but it's important to understand our reasoning to go this route. We're, as you may know from my previous slides, we originally started a fairly small team, but with a lot of ambitions. We're going to spend months on developing global solutions since we need to show some results and prove that our hypotheses are correct and deliver at least some solutions very quickly. Therefore, we immediately choose a strategy to focus on modeling and short iterations, but at the same time to keep the bar high for decisions we make. We focused on using several solutions and ready-made services that are available on AWS and Google Cloud Platform, as well as open source solutions that could speed up our development of ML models. Taking into account the size of the team, we try to achieve the maximum level of autonomy and efficiency for each team member. All of this influence the platform that we actually build. At the very beginning of starting working on the platform, we decided to highlight some of the goals that we want to achieve in order to be really precise with what we are building. We wanted to let data scientists to be fairly independent from data engineers and make quickly changes to machine learning models in production, but at the same time to make sure that the changes that they deploy and we can test and we can rely that they're not going to make negative effect. At the same time, we wanted to release models really quickly, and we wanted to have ability to share all our results with stakeholders fairly easy. For our use cases, since Delivery Hero is working in different countries with different brands, for us it was really important as well to be possible quickly parameterize our solution and our models in order to use the same model for different countries with slight variations based on the parameters. On the picture, you can see the platform that we built, which is based on Jupyter Notebooks. And the platform consists from three main parts. It's model development, model training, and model deployment. I will go into details of each part further with my slides, and we will start with model development. So the model development kind of the main tool set of data scientists in the process of working on the model. We used Jupyter Notebooks as the main, we used Amazon SageMaker as the main tool for developing ML models, which is built on top of Jupyter Notebooks internally. At the moment, Amazon SageMaker it became a bit bigger tool as it was when we just started 4 years ago. Right now, it's Amazon SageMaker Studio, which quite powerful, much powerful than it was back then. Why did we choose Amazon SageMaker? Just because it was essentially the platform that allowed us to use Jupyter Notebooks serverless without wasting our time on setting up different infrastructure and setting up a lot of resources around. It allows us to partially achieve some collaboration since Jupyter Notebook is available and SageMaker is available for everyone to use in the cloud. So multiple people can just simultaneously use it at the same time. It allows easy to scale up and scale down on demand, which saves us some money. At the same time, data scientist is not really dependent on the engineer and on the infrastructure underneath. And we managed to have great ability to customize environment for data scientists, pre-install different tools that would be really useful for data scientists and different plugins for Jupyter Notebooks. They would be just installed automatically as soon as data scientists spinning up Jupyter Notebook in SageMaker. As I mentioned earlier, we are trying to make the work of each team member as efficient as possible. We try to improve experience of data scientists by using different plugins for Jupyter Notebook, such as code predefine, execution times, and different plugins that would make the whole experience of using Jupyter Notebooks much easier for data scientists on a daily basis. At the same time, we did a lot of automation for SageMaker environments, such as stopping SageMaker when it wasn't active for some period of time, which help us to save the cost, and different automations around creation environment for data scientists inside the SageMaker. As well, we created a release stage for notebooks, including typical development practices such as CI/CD, containerization. So each notebook would be turned into Docker image. We would just push it and run it through CI/CD, run some tests, and then everyone actually can download the same Docker image and run it either locally or on own environment. One of if you ever used Jupyter Notebooks and try to review it in GitHub, you probably know how painful is it. On the left side, you see typical picture when you try to just see the difference in your Jupyter Notebook when you just push it to GitHub, GitLab, or something else. In order to tackle this problem, we actually find out one really useful service, which is called Review Notebooks, and played an important role in our entire modeling process. In short, this service allows you to render your Jupyter Notebooks on GitHub, and you can do typical review directly on GitHub of each line of Jupyter Notebook. So basically, essentially, you see the same Jupyter Notebook on GitHub as you would see it locally or in SageMaker. The Review NB is a paid service, of course, but you can achieve the same, maybe not the same level, but some kind of automation by using different Python libraries. But we chose to go with the paid service since we didn't want to spend much time on building something that already exists. When we started, it was quite cheap. Over the years, it became more expensive, but still it brings us a lot of value and drastically improved our process of developing and delivering ML models and make us the whole life cycle much shorter, because data scientists can iterate and review all the changes much quickly and deploy them to production. We trained, so when it comes to model training, we used Airflow, which as well was used for our data pipelines. As you can see, one of our use cases was to use different models for different countries, and with Airflow in different parameters, we managed to achieve it by simply creating different pipelines for each country, which basically are based on the same model but different parameters. And how did we actually run Jupyter Notebooks and turn it into ML models? Here we need to mention Papermill. And Papermill is a library developed by Netflix, which essentially kind of pioneered the healthy concept of using Jupyter Notebooks to run models. Papermill allows you to parameterize running and parsing Jupyter Notebooks. In our use case, we used combination of Papermill, Docker, and AWS Batch. So we would create a Docker image, as you seen earlier, we say after development on SageMaker, and then we would use Papermill in order to run it, to execute Jupyter Notebook itself with different set of parameters. We use AWS Batch for running Jupyter Notebook itself in Docker image as a serverless service. AWS Batch allows you to simply run a Docker image without worrying about infrastructure or scaling up. It's kind of serverless Kubernetes, I would say, on the AWS. How does Papermill looks in the practice? In the practice, you basically use Papermill library in Python. You specify different input and output paths for your notebook and different parameters. And then you need to set different tags in your initial Jupyter notebooks in order for Papermill to know that particular styles should be used as the parameters for this particular notebook. In this way, you can customize and change any parameter which presented in Jupyter Notebook itself. As you can see from the picture, we use different parameters and we managed, for instance, change just the country name or the number of trains or different features by simply changing parameters in Papermill. In our use case, we store all the parameters in YAML file in Airflow, which was super easy for data scientists to change. It means that every data scientist was able to change model version and any important parameters for model training themselves by changing the YAML file and basically deploying a new version of YAML file to Airflow, and Airflow will just pick up the changes and run model with the new parameters. As I mentioned earlier, we try to choose serverless solutions everywhere. So all the main models in training was done using AWS Batch. AWS Batch as well allows you to not worry about infrastructure, but only changing a CPU and memory, essentially just your resources. As you can see in the picture below, configuration for the resources needed to train each model listed along with the model itself. What does it mean? When, for instance, a new iteration of the model would run out of the memory, data scientists can self-serve and change those parameters in order to retrain the model again. It happened a few times for us, and it was one of the downsides of the solution that we wanted to improve. But still, thanks for the configuration, data scientists didn't need any help from data engineer because he can just apply the changes himself. One of the important concepts that we wanted to achieve was to have the ability to share our model results with stakeholders, because it was important to as well understand how the model was trained, what was the results, and the report that we would generate. We used not simply just sharing with our stakeholders, but as well for sanity checks by our data scientists. We created simple structure which for each model version, for each model and training data would just output a report as well based on the Papermill, and then data scientists can just review the results of the model itself. And it was really great for us to track down some issues and even take a look on the past, how the model was changing over the time. Of course, right now there are multiple different tools that can help to achieve the same, such as weighting biases. But back then, we didn't have time probably to invest in those tools. So we developed a simple solution that worked for us. When it comes to model serving, the procedure for launching model for real time is pretty standard for us. We use REST API services based on the Falcon or Fast API. And the service itself was just running on the AWS EKS. At the start, service would just pull the new version of the model and then periodically updates it as soon as we just publish a new model. We use the combination of, as well, again, Airflow and different Amazon services. However, for some of the use cases, since our company was multi-cloud, we still used BigQuery to get all our data. And as well, the reporting of the models was based on Google Cloud Storage, because in this way, this Google Cloud Storage will manage to share all the reports with the stakeholders by simply sharing the storage files based on the Google Cloud account, which everyone in the company had, which was pretty convenient way how you can securely share different data inside the company. As important aspect worth to mention is monitoring and tracking the quality of the values that our model produces. In addition to the standard solution of this problem, such as Datadog for monitoring, services BigQuery for collecting and then analyzing values, Data Studio for creating reports, it's like for notifications, we used Great Expectations as one of the main tools for running different data tests. Great Expectations is an open source library that allow you to create unit tests on the data and monitor how the metrics of the model changes over a period of time. This library supports integrations with many popular services and tools in big data and ML world, and particularly with Airflow. We used Great Expectations to keep track of values of our model that our model generates. And to do this, our data analysts have created a list of rules, expectations that we usually daily, sometimes every hour, would check, and then our model generates those values, and we'll just run Great Expectations based on the model output. In case we see some degradation, some issues, we just flag it via Slack. You can see again the final state of our whole ML platform, that not ML platform, but the platform that we developed. It was really good experience, and we did a lot of work and managed to come up with different smart solutions, I would say. And I think back then, when the market wasn't that big for different ML tools, and it was a good outcome. But at the end of the day, I would just summarize the results of the work that we did, and what was actually good. Our platform allow us to have really short life cycles of development, because we used open source tools that everyone is familiar with, and all the data scientists that joined our team later on the process, or analysts, for them it was really quickly to onboard, because they were mainly familiar with the Python, with Jupyter Notebooks, even if they never work with SageMaker. And the process of the reviewing was really easy for them. So the whole process of onboarding data scientists was just about 1 week or so, which was really great when you have fast-paced environment. Visualization and reporting based on the notebooks really helped us a lot to share results with our stakeholders, and for them it was really easy to understand what is actually going on. And for data scientists, it was super convenient, because he didn't need to create a lot of dashboards. So what he actually used, just Jupyter Notebook for development, and at the same time for running the model, and at the same time it was used to produce some reporting. Highly parameterized models allow us to quickly add new countries or new use cases. Especially it was really good when we started expanding to different countries. We could launch a new country in about like 1 or 2 weeks. What we didn't really like, it was our kind of downside of the whole platform that we developed. It works really well for simple models, since we mainly use just regression models and XGBoost. But if it would come to some bigger models and when you need more resources, it might not really scale that easy. Our models and the whole development life cycle didn't use a lot of data, to be honest, since we worked only with 3 months of data. That's why in case we would need to run some heavy ETL pipelines, the solution with Jupyter Notebook might not be that scalable, since we are running notebooks in Docker and they still pull some data. So in case you would need to work with big amount of data, it might be kind of challenging to scale up your environment. Despite that, our models we trained automatically. From time to time, we still run out of the resources and we had to manually change them based on YAML configuration. And this process was kind of manual, and honestly, I would rather avoid it in the future and make it a bit more after scaling. And probably the most important part, you need to have specific mindset inside your team. You need to really trust every person in the team, and you need to create an environment when people really taking care of the ownership of the solution and put a lot of attention to the quality of the work that they're developing. Because if you ever work with Jupyter Notebooks, a lot of people that treat them like it's a garbage or something that you would use just temporary. And you need to change this mindset, because in this case, you need to treat Jupyter Notebooks as something that you put to production and keep it tidy. Otherwise, the whole process is not going to work. It will fail and you won't be able to achieve good results. So the key takeaways, as I mentioned, it works really well for small and inexperienced teams. To achieve good results, you need to have really good quality monitoring of your models, and you need to have integration tests in order to catch any issues along the way. So basically, what worked really well for us, it's incorporating typical development like practices such as CI/CD, integration tests, and adding a lot of tests. Serverless is just amazing, and it's our future. It helps us to quickly scale up, scale down, and don't really worry about infrastructure. Focus on our use cases, focus on how can we improve the product, and don't really worry about, hey, how I need to develop something that already exists on the market. And code review, of course, which is really such a powerful tool, which for some years wasn't that popular in data science world, but I think it must become one of the main steps in everyone's workflow in order to avoid any issues and simply just sharing the knowledge. I think, yeah, that's pretty much it from me today.
Thank you very much. It was very interesting presentation. Nick, it was amazing. Thank you. Congrats on your first meetup event, first meetup presentation. It's done. It's done. Amazing job. Great job, man. Thank you everyone for joining this meetup today. I am really glad to see people who joined us multiple times. If you would like to join us in April, we are going to talk about serviceful development. It's quite magical stuff nowadays. It means, for example, you can start using API gateway, and you can start using DynamoDB. And instead of using Lambda in the middle, you can connect API gateway to DynamoDB and don't pay for Lambda call. Pay only for resources that you use. It gets absolutely insane latency. For example, like you don't have any type of call start about all of this stuff, like how to do all of this stuff, like what kind of possibilities like you have, what kind of challenges you have. We're going to talk on April 5th. Join us. And yeah, see you in April. I was glad to see you today. Bye, everyone.